Hello everyone, it's our pleasure to present our ICCV paper core, Group-Aware Contrastive Regression for Action Quality Assessment. AQA, aiming to evaluate how well a specific action or skill has been performed, is more challenging as it requires the model to predict fine-grained scores from videos that describe the same action. Many efforts have been made to tackle this problem over the past few years. Most conventional approaches formulate the AQA as a regression problem, where the scores are directly predicted from a single video. While some promising results have been achieved, AQA still faces two challenges. First, since the score labels are usually annotated by human judges, the subjective appraisal of judges makes accurate score prediction quite difficult. Second, the difference between videos for AQA is very subtle, since actors are usually performing the same action in a similar environment. We argue that a key to addressing AQA is to discover the differences among the videos and predict scores based on the differences. Towards a better AQA framework that can utilize the differences among the videos to predict the final rating, we present a new pipeline, called Contrastive Regression for Action Quality Assessment, which incorporates the ranking idea into the conventional regression framework. So we change the formulation of AQA from regressing the target score directly to predicting the difference between target action and exemplar action. The final score for target action can be obtained by adding the difference and the score of exemplar up. By encouraging the model to predict the final relative score, the model is naturally guided to focus on the subtle difference in original videos. And during the inference, the multi-exemplar voting strategy can effectively reduce the influence of human subjectiveness. We borrow the merits from the concept of contrastive learning. Contrastive learning aims to learn a better representation space where the distance dA between two similar samples x and xa is enforced to be small, while the distance dB between the dissimilar ones x and xb are encouraged to be large. Therefore, the distance in the representation space can already reflect the semantic relationship between two samples. Analogically, in the context of AQA, we aim to learn a model that can map the input video into the score space where the differences between the action qualities can be measured by the relative scores. This is our pipeline. We first sample an exemplar video for each input video according to the category and degree of difficulty of the action. We then feed the video pair into a shared I3D backbone to extract spatio-temporal features and combine these two features with the reference score of the exemplar video. Finally, we pass the combined feature to the group-aware regression tree and obtain the score difference between the two videos. During inference, the final score can be computed by averaging the results from multiple different exemplars. The conventional regression head takes the feature as inputs and directly predicts the results, which is not the best choice in our pipeline. We devise a group-aware regression tree, GART, to solve the problem in a divide-and-conquer manner. We construct a series of binary in each layer of the tree. The model tries to compare the input video and exemplar video in each node. The final decision will come from a regression in a small interval. We present the distribution of the differences of scores in the training set under different partition strategies. Picture A is a uniform partition. We can observe a large variation of frequency among different groups, so we propose a group-aware grouping strategy. The distribution after this strategy is shown in picture B. Groups are divided based on the relative score distribution to make the sample in each group balance. In order to verify the effectiveness of our approach, we conduct experiments on 3 datasets including Olympic Games and surgical activities. We propose the relative L2 distance as a new metric to cooperate with Spearman's correlation, since Spearman's correlation focuses more on the ranks of the predicted scores while our RL2 focuses more on the numerical values. The performance under Spearman correlation and the newly proposed RL2 results on 3 datasets are shown in the table. Our method establishes new state-of-the-art under both metrics, which demonstrate the advantages of our methods compared with other methods. In this figure, we show the inference procedure of our regression tree. The feature from the target video and exemplar video are sent into the regression tree. In the first layer of the tree, the model tries to determine whether the target is better than the exemplar. And then, with the layer goes deeper, the decision will be made more concrete. Finally, we can obtain the difference score by conduct a simple regression in the chosen group interval. Thanks for listening.